Happy Wednesday, everyone. Welcome to Water Wednesday. My name is Yiling Zhang. I'm the Water Resources Regional Specialized Agent in University of Florida IFAS Extension in Central District. Water Wednesday is a webinar series about Florida's precious resource, water. Every Wednesday afternoon at 2 o'clock Eastern Time, we will live stream a 30-minute talk about Florida's water and what we can do to protect it. May is the National Wetland Month. Therefore, all the Water Wednesday topics in May focus on wetlands. In last several Water Wednesdays, we gave an overview of the Florida's wetlands and constructed wetlands. If you missed these talks, I will post a link in the chat box to the recordings, so you can watch the recordings and catch up with some basics of wetlands. Today, we will focus on wetlands as a tool for water treatment. Before I get it started, I want to let everyone know we are hosting this webinar series on both Zoom and Facebook Live. There are about 10 seconds delay between Facebook and Zoom. So if you ask any questions, you can put your questions in the chat box. And for Facebook viewers, you can also put it in the comment section. I will address all the questions after this brief talk. And for our Facebook viewers, I also want to remind you, be aware of scammers. This event is free. We don't charge anything for this webinar series. So please be aware of scammers and do not click any links that are now posted by the admin. So now let's get it started. Just a quick recap. What is a wetland? So in last two Water Wednesdays, we went through some basic concepts of wetlands. Generally speaking, wetlands are the transitional areas between land and water that encompass a broad range of environments, including marshes, swamps, floodplains, tidal zones, and more. Each of these environments have slow-moving, shallow waters at or near the soil surface, at least for part of the year, including the growing season. The hydraulic conditions, the plant communities, and the unique aerobic and anaerobic interface between water and soil support various physical, chemical, and biological processes that improve water quality. Therefore, wetlands are often referred as the natural kidneys because of their ability to remove pollutants from water via storage in the soil and vegetation, as well as through losses to the atmosphere. Utilizing wetlands to treat water can be traced back to mid-20th century. Today, natural wetlands and constructed wetlands are used globally to treat contaminated waters. Contamination can be any constituent in water that causes human or environmental harm. So here in this slide, it gave you some idea where we can use wetland to treat wastewater. Wetlands can treat wastewater from many different sources, including agricultural production, stormwater, mining, petroleum refineries, pulp and paper mills, and landfill leaches. These pollutants include physical contaminants, such as suspended solids, chemical contaminants, both organic and inorganic, and biological contaminants, such as pathogens. Some of these contaminants, such as nutrients, may be harmful before a certain threshold. Nutrients become problematic when high concentrations of nitrogen or phosphorus cause excessive plant and algae growth. During the composition process, microorganisms feeding on debris from aquatic plants and algae use available oxygen in the water column, leading to low dissolved oxygen concentration, then cause fish kills. So today, natural wetlands are considered waters of the United States. The federal regulations discourage their use for wastewater treatment. Current regulations only allow natural wetlands to receive wastewaters that have undergone extensive water treatment by conventional processes at wastewater treatment facilities. Therefore, existing natural wetlands receive water that have already undergone secondary or tertiary treatment. The processes of treating wastewater in treatment wetlands after it has undergone secondary or tertiary treatment is usually called polishing. Polishing is often a final step to reduce concentrations of contaminants in wastewater before discharging it to local surface waters. In natural wetlands, wastewater should be well distributed throughout the wetland for effective treatment. And the natural hydrology of wetland should also be understood and mimicked to support local vegetation. So therefore, they are constructed wetlands. For constructed wetlands are designed to mimic the natural biological, chemical, and physical processes of a wetland while allowing for greater flexibility and control. Constructed wetland can provide some or all of the function of secondary and tertiary treatment. In next slide, I will show you what secondary and tertiary treatment is. According to the U.S. Environmental Protection Agency data in 2017, there were approximately 1,000 constructed wetlands in U.S. in operation that receive a wide range of wastewaters. Generally, they are built in uplands or outside of the floodplains by establishing water control structures to create a desired hydrological flow path. Although treatment wetlands require a large amount of wetlands, they are more cost-effective to operate and maintain than conventional methods of wastewater treatment because they require little energy and operational attention. In a constructed wetland, the flow is controlled, so the water is spread evenly among wetland plants. In natural wetlands, 90% of the water may flow through small channels. Controlling the flow allows the natural processes to occur and clean the wastewater more efficiently. It is important to maintain an even cross-sectional flow throughout the wetland to assure proper treatment. The wetland has the possibility of becoming plugged with debris and organic matters, which will prevent even cross-sectional flow. This diagram illustrates how wastewater is treated in a wastewater treatment facility, from primary to secondary to tertiary. So primary treatment is a physical settling process that removes solids. Wastewater that enters the primary settling tank is slowed down to enable the heavier solids to settle to the bottom. Lighter materials, such as grease, will float to the top of the tank. Settling tanks are designed with mechanism to remove both the settled solid as well as the floating solids. Primary treatment generates a primary sludge. The sludge is removed and pumped to solid treatment process for ultimate removal. The wastewater still has solid remaining after primary treatment. These solids are either dissolved or suspended. Dissolved solids are very small solids. You cannot see the solid, but there they are. Suspended solids can be related to the same ends of a magnet. The solids repel each other. These solids are small but are visible to human eye. We remove these solids and suspended solids through the next phase of treatment, secondary treatment. Secondary treatment is a biological process. It is used to stabilize the dissolved solids. Microorganisms such as bacteria feed on organic solids in wastewater and convert the organics into biological mass that can later be removed. These biological processes are aerobic. Oxygen must be provided for this aerobic organism to work properly and efficiently. An integral part of secondary treatment processes is another set of settling tanks. Some treatment plants may be required to remove nutrients, including nitrogen and phosphorus, due to the possible negative impacts on the receiving water bodies. Tertiary treatment, it is also called advanced treatment, is used to remove nutrients and additional solids. Tertiary treatment provides a very high level of treatment that goes beyond the secondary treatment. In the case of nitrogen removal, the processes are biological. For phosphorus removal, chemical additives are normally required. From this quick illustration, you can see conventional wastewater treatment is high in energy demand and operational maintenance. That's why constructed wetland, we built wetlands. Constructed wetlands provide simple and effective wastewater treatment. They can be used to treat domestic, agriculture, industrial, and mining wastewaters. Their construction costs are much less than a conventional system, usually around 50 to 90%. And their operation costs are also very low. You do not need trained professionals. Sometimes you don't even need full-time staff to operate or just to watch the system. Constructed wetlands are also pleasant to look at, just like this picture, the background picture. They attract desired wildlife and provide environmental education opportunities. So how do constructed wetlands work? Wastewater flows through a pipe from primary wastewater treatment system into the constructed wetlands. Wastewater can either flow on top of the existing soil or through porous medium, such as gravel. If it's above the soil, we call it surface. Under the soil, under the surface, through the gravel medium, we call it subsurface. Flow is distributed evenly across the width of wetland cell. A waterproof liner is used on the sides and the bottom of the cell to prevent leaks and assure adequate water for the wetland plants. This cell is planted with wetland plants such as cattails, roots and stems of plants from a dense mat. In that cell, chemical, biological, and physical processes occur to treat wastewater. Water levels are controlled in both surface and subsurface system. In subsurface system, the normal water level is kept 1 inch below gravel surface, which improves the treatment and controls mosquitoes. A second cell or a third cell may be added for more treatment. There are two types of constructed wetland. One is called a free water surface flow, and the other is called a subsurface flow system. So first, let's look at free water surface flow. So these two types of systems differ in their hydrology, and the type of construction will depend on the specific contaminant removal design and also the regulatory needs. And for this system, free water surface flow wetlands, they contain a shallow layer of surface water that flows over a vegetated soil surface. A free water surface system can be natural wetland. It can also be constructed wetlands. For constructed free water surface flow systems, they look just like natural wetlands. As surface waters flow through the wetland, particles settle, and the chemical and biological process retain and transport contaminants. Surface flow systems represent about 60% of the treatment wetland system in North America. They are generally less expensive than subsurface system. Free water surface flow systems do require more land, especially if the wetland is designed to remove nutrients. Because of the size requirement, free water surface flow systems are often used as polishing systems for wastewater. So for polishing means after secondary or tertiary treatment. The other type of constructed wetland is subsurface flow. In subsurface flow wetlands, the water flows beneath the soil surface through porous medium, either vertically or horizontally, and the roots penetrate the soil. These type of wetlands provide habitat for certain species of emergent vegetation and act as a filter by removing solids and the nutrient from water as it flows through a saturated porous sand, gravel, or soil medium. Bacteria, along with emerging aquatic vegetation, uptake and transform contaminants as water flows through the wetlands. Some of the advantages of subsurface flow wetlands are they prevent public contact with partially treated wastewater. They do not provide mosquito breeding habitats. They require less land, and also they reduce odor. However, the major disadvantage is they are difficult to build and also expensive to build. With the porous medium, they are prone to clogging. So nowadays, we are seeing more hybrid systems, which use both surface and subsurface water flows. These systems are useful in providing both aerobic and anaerobic conditions necessary to support bacteria-driven water treatment processes. As a result, hybrid systems can be more effective at treating certain contaminants. Just a quick recap, how wastewater treatment in wetlands differ from conventional wastewater treatment facilities. In constructed wetlands, as wastewaters flow through the system, suspended solids and trace metals settle and are filtered. Plants and organic materials also absorb trace metals. Organisms that live in water, on rock, or in soil and on stems and roots of wetland plants use these organic materials and nutrients as food. Plants provide much of the oxygen needed by the organism to live and grow. Plant roots keep the rocks or soil loose so water can flow through easily. So it sounds like constructed wetlands are great. So why are we now using constructed wetlands to treat all wastewater? Here are some major limitations. First, it's the lack of standard information for engineers is currently limiting the design and the construction of effective low-cost systems. Constructed wetlands may not be effectively treat some type of complex pollutants because most constructed wetlands are used as a secondary or even tertiary treatment. Most constructed wetlands are used after secondary and tertiary treatment, more like as a polishing process. In addition, this system also needs more land than conventional systems. High land cost and the lack of suitable land can make construction of large systems impractical. Sites, on the other hand, if the site is relatively flat, have deep soil and a low groundwater table, then they are ideal for a constructed wetland. If the site has high water table, then probably it's a not good choice. Something else to consider is the mosquitoes. So with the water, standing water, mosquitoes can be a problem, but this can be prevented or controlled with proper system design and management. So let's go to this question. After you heard we use constructed wetland to treat wastewater, then are constructed wetland for you or for your communities? So the answer actually, it varies. In most cases, constructed wetland will answer many, but not every wastewater need. They may be used by small towns, developers, small business, individual homes with failed septic systems, farm operation, and some type of industry. They meet secondary treatment requirement. They can also be designed for advanced treatment. Their construction and operation costs are relatively low, especially compared to conventional wastewater treatment facility. And they do not need operators who are highly trained. So a good case will be some rural areas where they have problems meeting today's strict water quality standards. Because most rural areas, they don't have centralized wastewater treatment systems. Then constructed wetland can provide them a good wastewater treatment alternative. Smaller vision can also be built to meet the needs of homes with failed septic systems. Constructed wetland can help us improve water quality as they learn more and apply them effectively to treat various type of wastewater. So here is the some references for this talk. So this talk doesn't mean to give you a lot of technical information, just want to give you an overview how we can utilize constructed wetland to treat wastewater, utilize this natural process to help us improve water quality. With that, I'm happy to take your questions. And first, let me post a link if you want to watch the previous recordings. I uploaded all the recordings to our YouTube channel, so you can find it here. And meanwhile, let me go to our Facebook page. So let me post it here. So if you have any questions, you can put in the chat box. If you don't have any questions, I post a link here. It's just a short survey. I will appreciate you can click this survey link and tell us how we can improve the Water Wednesday series. So let me check if if we have any questions on the Facebook end. I don't see any questions here. So I hope this short and sweet talk address your questions and just give you a basic understanding how we can utilize constructed wetland to improve our water quality. With that, I appreciate your time and hope you can take the survey and help us tell us how we can improve the series. So with that, I will finish today's webinar and hope you all have a good Wednesday afternoon. Bye now.